Happy Wednesday, end of another week. Hard to believe. The idea of today is to look at transformations. So given the graph of a function, right? So you should have been given the graph of basic functions. Obviously, everyone knows x, right? X squared, x cubed was given, I think. Absolute value of x, 1 over x, square root of x. I think even cube root of x was given. So given those basic graphs, I think the book calls them toolkit functions, we can sketch the graph of other functions. Right? These other functions are transformations of these toolkits. There are 3 broad types of transformations. There are translations, of which there are 2 types. You have a vertical translation and a horizontal translation. You have a reflection, again, 2 types, a vertical reflection and a horizontal reflection. Right? And then you have stretch and compression, again, 2 types, horizontal and vertical. I believe we also studied the absolute value of x a little bit. So first 4 problems are going to deal strictly with the absolute value function. Can't get enough government work. Right, and that's the graph of absolute value of x.
Sorry, I was running late. Psychedelic, man.
So that's going to be a fine of $500 for the echo. Payable only in cash. Okay. Absolute value of x minus 1. Well, notice what it's doing to the output. We're subtracting 1 from the output of absolute value of x, right? This tells us that it's affecting the range. Range is vertical. This is a translation 1 unit downwards. That would be negative 1 there, right? Let's say that's 1. And that's negative 1 on the x-axis. That's the absolute value of x minus 1. All right, took the graph of absolute value of x and moved it down 1 unit.
So translation is like a slide.
Mhm.
You're sliding it. But is it always vertical?
No. You can have vertical and horizontal.
Oh, if you put something inside the absolute value.
And if it affects the domain, then you're shifting horizontally, right? You're going to shift along the x-axis. Speaking of which. Absolute value of x minus 2. Now this is actually inside the function.
Going to go to the right, slide it to the right too, correct?
This goes to the right too.
Because then when x is 2, y is 0.
Yes, right. Because it's actually within the function itself, right? So it's like f of x minus 2. That's affecting input, right? That tells you it's horizontal. That's just a matter of, is it right or left? With horizontal translations, it's the opposite of what you would think. Right? You'd see negative and think left. No, it's the opposite of that. It's right. For that exact reason. Well, absolute value is always positive, but I'm just talking about domain. We're just talking about how's it affecting the graph. Right. So y equals 0 occurs when x is equal to 0 for just absolute value of x, right? Y equals 0 here occurs at x equals 2. That tells you it's shifted 2 units to the right.
But the domain is still negative infinity, positive infinity, right?
In this case, yes. Right, but what actually happened was the domain did shift, but because it's minus infinity to positive infinity, you don't see that shift.
Negative infinity plus 2, positive.
Yes.
Oh.
Right, because it's the entire real number line, you don't actually notice the shift. Right, it'd be like you have, let's say, what's our national debt?
A trillion.
32 trillion. Let's say you have $32 trillion in your bank account. You lose $5.
Yeah.
Do you notice? Right, it's kind of that argument. Because it's so large, you don't notice a minuscule change. Oh dear. Right, this is a translation 2 units right. And then when is it going to cross the y-axis? At 2. It's going to be good enough. And so there'd be the graph of absolute value of x minus 2. Here we have absolute value of x plus 2 minus 1. That plus 2. You have your hand up? Right? It's inside the function, so it tells us it's a horizontal. Plus 2 is telling us it's going to the left. And so 2 units left. It actually does. If you really sit there and study it, it really does. And 1 unit down. There's 1 unit down, let's say. 2 units to the left. Those are going to be the new vertex. Where's it going to cross the x? It'll cross at -1 and -3. And where's it going to cross the y? X is 0, so yeah, it'd be 1. So there's the graph of absolute value of x plus 2 minus 1.
Find out where it crosses the y-axis. And said it was 1. And we know it because
What's the x coordinate along the y-axis?
the x coordinate on the y-axis. 0.
So just plug x equals 0 in.
Uh,
And that tells you what y is. -2 times the absolute value of x plus 3. We have 3 translation, or not translations. We have 3 transformations here. So that negative scalar multiple is telling us we have a reflection.
The -2 is telling us that.
Well, just
More specifically, the
negative
negative.
sign.
The 2 is going to tell us something different. The fact that it's negative is telling me I'm going to have a reflection. Question is it going to be a horizontal or a vertical? So vertical reflection would be a reflection about the x-axis. A horizontal reflection is a reflection about the y-axis. Right, so what's being affected? The output or the input? Output, right? So the y values are changing, which means it's reflecting about the x-axis. That 2 is also telling us something. That 2 tells us we're either going to have a stretch or a compress. So the graph is either being stretched out or compressed. Again, what's being affected? The inputs or the outputs?
The output.
So it's going to be a vertical stretch or compression. For vertical, if the constant is greater than 1, then it's a stretch by that factor. If it's less than 1, and it's always going to be greater than 0 because the negative tells you it's a reflection.
When you say constant,
The 2 is the constant.
then what is 3?
I'm ignoring that. I'm talking just strictly about constant multiples. The scalar multiple.
You wouldn't call it a coefficient of the absolute value?
You can call it coefficient, but that means something different.
All right.
Specifically, coefficients are for polynomials. This is not a polynomial. If the constant is less than 1, then it is a compression by a factor of its reciprocal. Right, so if it was 1/2, you'd be compressing by a factor of 2. This is greater than 1, so it's a stretch. Vertical vertical.
Yeah.
I think it's CAL, yeah.
Yeah. Better be.
I'm not a major. I'm not an English major, so I don't care. I know how to spell.
I know it's not like icicles.
So the vertical stretch by a factor of 2. All right. Now that plus 3 is a translation. Three units upward. That is technically the order in which this is happening. So first the graph is going to be reflected, then it will be stretched, and then moved up. In terms of actually graphing it, though, doesn't really matter. Note's moving up 3 units, so there's going to be my vertex. The fact that it's reflecting about the x-axis tells me it's now going to open downwards instead of upwards. Now the toughest one, the stretch. So this is the original shape. Vertically stretching it. It's going to make it look more like that, right? It's going to start to slender out the opening. But it's by a factor of 2. Yeah. Getting it perfectly to be a factor of 2, if you can do that, you're a psychopath. I want nothing to do with you. So we're just going to do the best we can because, you know, it's just a sketch and it'll be good enough for government work. Here's how I'm going to go about it. I'm just going to plot some points. Specifically, let's look for the x-intercepts. So y being 0, we'd have to have x being plus or minus 3/2. Oh, of course it gives me fractions because why not? I'm going to say, let that tick be 1, let that tick be 2. Oh, that's not perfect. Looks about right. That'd be -1. That'd be -2, right? So it'll cross exactly halfway between them. That'd be a sketch of our graph. Good enough for government work.
So you're really multiplying the slope of the line by that stretch factor, right? Went from, like, on the right half, slope -1, now it's slope -2, right?
Yes, but be careful.
Only for linear stuff.
Right. Technically, this is not linear, right?
Well,
But each piece is linear, so that's why that works.
only, yeah, very limited.
I mean, that argument is still valid, by the way. It just requires the idea of tangent lines and slopes of tangent lines, which is calculus, which we're going to just ignore.
So just find the zeros on the x-axis is the way to go.
In this case, by the way, if that was flipped upwards, that wouldn't work, right? Because it wouldn't be crossing the x-axis. So then we'd have to plot different points. I've already done my time suffering sketching graphs, so it's not my problem, it's yours. show you my favorite program. Which you're not going to be allowed to use. So I'm going to have Mathematica plot the absolute value of x and then those 4 problems just to show you how they all compare. All right, so what was the first one? It was absolute x minus 1. Then it was absolute of x minus 2. Then it was absolute of x plus 2 minus 1. And then it was negative 2 absolute of x plus 3. Let's go minus 10 to 10. Green, yeah, it's not going to show up.
Purple.
So yeah, green. I'll do 5 and plot tables, expressions. See how this turns out. And of course, after that takes a while to wake up. There we go. So there they all are. Also, do this. Let's see if I remember how to do this. No, it doesn't like that. Why doesn't it like that?
This is what you had to do when you met by writing out math problems in code.
Yep. Doesn't it like that? Okay, so for some reason it doesn't like this command. No, that shouldn't be there. Oh, crap. Because I used the wrong command. That's it. Victory is mine. All right, so what this is going to do, oh, I don't want it to go 1 through 10 though. I want it to only be integers. If I do that, does it recognize that to increase it only by 1? It does. Excellent. Right? So look how the vertical stretch affects the graph. As it goes from factor 2 to 10. Right, so like I said, it's literally stretching out. Versus if we do a compression, (0.11) and change it by 0.1 each time. Except now I want it to go backwards. It starts to flatten out, right? So you can kind of imagine squishing it, stretching it. What about horizontal compression stretching though, not vertical? Right. So we'll start at 1, right? So again, if you're dealing with horizontal, anything that deals with the input is the opposite of what you would think. So if you're so in this case, absolute value k times x, if that k is less than 1, it's a stretch horizontally, not a compression. Right. And again, it's a stretch by a factor of 1 over k, the reciprocal of k. And again, you can kind of imagine it, right? Look what happens. You can see you're kind of stretching it horizontally, which is, by the way, very similar to a vertical compression. It's not quite the same, but they have the same effect.
This is stretching on a horizontal
Yes.
line.
So this is a horizontal stretch. Right. So again, you can kind of picture, you take the graph and you just kind of stretch it out. That's what you would imagine the graph does.
Compressing it.
Right. This compressing, which, because again, you can kind of imagine you squish it together vertically, you kind of imagine the graph is going to elongate. Right. Even you just take a dough ball, right? If you press down on it vertically, it's compressing, right? But what happens horizontally? It stretches out.
You have a tortilla.
Actually, you don't quite have a tortilla. You have to do other things to it, like cook it. I was thinking more along the lines of pizza dough. Go for a nice pizza. That's not even pizza anymore. Sorry. Only pizza is true Italian pizza. Which they don't call pizza, they call tomato pies. So good.
Columbus.
Nonsense. I have a great Italian place that opened up near me. Best pizza I've ever had. That'd be giving too much information away. Next thing I know, I'm gonna have stalkers.
How about north or south?
From here south. Now we're going to look at a vertical compression. Not vertical, I'm sorry, a horizontal compression, right? So again, kind of imagine you squish it horizontally, you can kind of picture what's going to happen. And again, same effect as a vertical stretch. And then of course, if that K happens to be negative, right, it's just a reflection and then a stretch or compress. Right, so we always say K is positive. If it turns out to be negative, you just take the positive and say the negative is a reflection. That's all there is. Right now, imagine trying to visualize this without technology, like back in the Stone Age when I was in school. Back when you had to watch out for dinosaurs when you left your house. You shouldn't be laughing, mister.
Rotary phones.
Oh yeah, I
Can I
remember
get
those.
any, man?
I remember those. Back when if you wanted someone to pick you up, you had to call collect and like talk real fast because no one would ever pay the charges. You have a call from come again. You youngins have no idea how hard it used to be. Street lights came on, you knew you were getting an ass whooping if you weren't home.
That was still a thing. That was still a thing.
I used to pay for all the time.
Remember the old internet connection?
Oh, sure.
The sound.
40?
The sound.
Oh,
And then God forbid someone makes a phone call when you're on the internet. Oh, those were the good old days. Back when I didn't have to worry about bills. What was the biggest lie you were told? You want to be an adult? Naked again. Next four are gonna right? Yeah. Next four deal with square root of x. Square root of negative x. And by the way, this is a great chance to look at how domain and range are affected as well. Right. We're multiplying inputs by a -1, right? That means the input is what's being affected. Domain is going to change. Originally, square root of x, domain, what? 0 to infinity, right? Well, now if you multiply the inputs by -1, the domain becomes negative infinity to 0. That negative tells us it's a reflection. It's the inputs that are being affected. So it's a horizontal reflection, which is across the y-axis. And that's the only transformation that this one gives us.
When the input is being affected, it's on the horizontal.
Yeah, right, because the input's what? It's the horizontal axis, right? So if you're affecting the input, you're affecting the horizontal axis, so it's going to be something horizontally. Either translation, a stretch or compress, or reflection. Square root of x looks something like this. Again, it's good enough for government work. If we reflect it across the y-axis, just be something like that instead. So there we go. -3 square root of x. Negative tells us we have a reflection. Horizontal or vertical?
Vertical.
Okay. Which means the range is being affected. Right, so range originally is what? It's also 0 to infinity, isn't it? For the range of square root of x. Right? Negative means range is now negative infinity to 0. So reflection across the x-axis. It's also being multiplied by 3. Is this going to be vertical or horizontal? It's also vertical. This is a vertical stretch by a factor of 3. Right, so the range goes from 0 to infinity to negative infinity to 0. You're not going to notice the stretching because 3 times negative infinity is still negative infinity, right? And 3 times 0 is still 0. So you don't actually notice the range stretching, but it does. Bummer. We're not going to have any x-intercepts to sketch. There's 1. So it's going to be down to -3. Looks good. 4 is going to be down to -6. -6 looks like, based on my scan, is going to be somewhere down there. Something like that, probably.
One.
Where?
Where the point is. Oh, 1, -1,
This one? No,
1.
that's 1, -3.
Oh, that's a -3? Okay.
And this would be -6 down here. How do I get what? What's the square root of 4? 2 times -3. That's why I did 4 and not 2 or 3. And because they don't have integer square roots.
Math book from the 50s where they actually teach you how to do square roots by hand. It's brutal. Did you ever have to do that?
Never had to, but I was taught how to. It's very similar to long division.
Yeah, but messier.
The concept's the same, so it makes it nice. I just happen to know that root 2 is about 1.41. Because it's something we work with a lot. Root 3 I know is going to be close to 2. I think root 3 is like 1.8. Somewhere around there. One half square root of x plus 3. Are we going to have a reflection? No, so that's good. What does that 1/2 tell us? What kind of compression? Vertical compression, what's the factor? Factor of 2, right? So it's going to be compressed vertically by a factor of 2.
Because flat rate has to.
All right, so it's the same idea. If I say something shrinking by a factor of 2, it means that it's halving. Do we have another transformation? What kind?
You said transformation?
The translation, right?
What kind of translation?
Left 3.
Right, so horizontal translation,
Oh, horse.
left 3 units. You say left, I know it's horizontal, that's fine. Flatten it by a factor of 2. Well, flatten it, so vertically compress it by a factor of 2. Which again is going to be rather fun. So it's going to start now at -3, right? So when x is 1, y is 1. That's root 4. Root 9 would be 3/2. Root 16 would be 2, and 16 is way off my scale. Because I would need what I need to put x equals 13 to be that.
13,2.
Hoopers. Well, I'm guessing we have to do -2 1/2. I'll be there. And then when x is 6, it's to be 6 right there. Y would be 3/2. So that's going to be right about there. That should be enough for me to kind of sketch the compression. Something like that. Good enough for government work. And don't even try and figure out where it's crossing the y-axis because it's not an integer or a rational. It's root 3/2. Cosine of pi over 6. So y is -1.5 square root of x minus 1 plus 2. How many total transformations do we have? How many? What are they? What kind of reflection? Okay.
Compression. No, then you have the translation. And that's gonna be to the, right.
How many units?
+2 and that. I don't put that one.
That one was move up one, move up two.
Another translation.
Yeah, a translation, 3, 2 units.
Right, well, that's 3 transformations. It's the 4th.
The vertical stretch.
What's the factor?
By 1.5.
So it's going to be stretched vertically by a factor of 1.5. Oh, this will be fun. Now let's first tackle the translation. So 1 unit to the right, 2 units up. So there's where we're starting. Flexion about the x-axis, so it's going to be upside down. That means we're going to cross the x-axis at some point. Good, I'm gonna plot that point. Set y equal to, oh boy, that's gonna be fun. Okay, set y equal to 0. We're gonna have what, -2. All right, divide -2 by 1.5, so that's gonna be +4/3. Oh, that sucks. Square it gives us 16/9. Add 1 is 25/9, which is slightly less than 3. Bugger. How much less than 3? It'll be what? It'll be 2 7/9. Yeah, 2 7/9. So pretty damn close to 3. I don't know. That looks like 2 7/9. For government work, it's acceptable. Which means it's going to be a bugger to. We're going to use our imagination and say it crossed at that point. And say, yep, that looks good enough.
Are we able to tell if it's a vertical stretch again?
If the function is being multiplied by some value, right? So you're multiplying after the function. So like 8 times f of x. And so what's being affected is the range, the output. So that tells you it's going to be a vertical stretch or compress. The size of the constant tells you if it's a stretch or a compress. Greater than 1, it's a stretch. Less than 1 is a compress. And remember, it's always going to be positive, right? Because negative just tells you it's reflecting. So you just look at the absolute value of the constant. Yes, right, because the negative flips it, and then the 3 stretches it. So just think of the negative and the k as separate entities. I think it was like -1 times k, and that -1 tells you it's a reflection. Oh, you were still playing. Oh dear. That wasted battery power. So, square root of x. Let's see how good we did. Square root of -x. -3. Square root of x. Half. Square root of x plus 3. -1.5 square root x minus 1 plus 2. And for the rest, let's get the same options. So copy, paste. Oh, I like that shape. I like what the square root of -x and -3 square root of x do. Makes a nice little S shape. Hey, that last one looks pretty close to what we drew, so I'm gonna go with it. Yay! Did pretty good.
Oh, geez. I thought one of the gray lines was a function, the negative, the root negative x. I'm like, how the heck? No, that's pointing over.
Yes, it's
Okay, the light grays are not.
yeah, they're lines pointing to the. Could also do this instead of plot labels. Plot legends. That is not green. I don't know how that comes up with that being green. It's like lime green.
It's Seahawks green.
Who are the Seahawks?
Yeah, Seattle Seahawks, those crazy neon football uniforms they got,
Yeah, they're an irrelevant
Like-
team.
radioactive.
They're an irrelevant team, so don't know who they are.
Ah,
This Sunday's gonna be fun.
What are you, Eagles fan?
Nope. My dad is. And I hope the Eagles lose.
I'm gonna be in an airplane. Planning this trip like 3 months ago, didn't even think about Super Bowl Sunday. Thankfully, the Jets are not in it, but then again.
Who are the Jets?
Yeah. I've been waiting my whole life, you know.
The Jets should just be like a little league team. Actually, that's an insult to little league.
JETS, just end this season.
That's every season, yeah.
Yeah.
Little league plays better than the Jets. I bet a high school team could beat the Jets. They're awful. I didn't think it was possible a team to be that bad for so long. Although, look on the bright side. At least you're not the Cowboys. Questions on transformations.
Translation.
Transformations. They're all collectively known as transformations. Easy, right? There's like no math involved.
A lot more to understand.
Mhm.
Conceptual. No algebra required. No. Suppose I could look at some absolute values. Absolute value function, right? So you're all familiar with what an absolute value does. Right? It measures, essentially, if you're looking at it graphically, it measures distance. It makes every value positive, right? However, you've never really thought of it functionally.
Lines.
Means defined. So the absolute value of x is a piecewise function. Right? So again, think of absolute value as a machine. If you throw in a non-negative number, the machine is going to spit out that number, right? Put in 0, it gives you 0. Put in 10, it gives you 10. Put in pi, it gives you pi. If you throw in a negative number, what does the machine spit out? Right? So if you throw in -3, if you throw in -10, how do you get 10 from -10?
Negative X.
So if you throw in a number, a negative number, the absolute value spits out the negative of that negative number. This is the definition of absolute value. It is also an extremely important definition. You will need it for calculus. Other important features. Absolute value of x equals a. If and only if, right? So this is meaning that if we know the absolute value of x is equal to a, it means x equals -a, or x equals +a. Less than or equal to. -a less than x less than a. What this means. Again, this is a very important concept. Absolute value of x being greater than a means that x is either less than -a or it's greater than a. And then, of course, greater than or equal to has a similar meaning. A property of absolute values. A very popular property is known as the triangle inequality. But this says for all real numbers, A and B, or X and Y, I'm going to use X and Y, that's more common. The absolute value of X plus Y will always be less than or equal to the absolute value of X plus the absolute value of Y. Why not? I got time, I'll prove it. This is what math is all about. So we're going to say X and Y are going to be any arbitrarily chosen real numbers. Yeah. If you take a look at X plus Y all squared, right? We have, that's obviously X squared plus 2XY plus Y squared. Which would be less than or equal to X squared plus Y squared. Right. But it's nothing of a proof of a different triangle inequality.
Would they have to be positive for that to be true? Both positive?
They could also both be negative.
Or what if one of each?
Yeah, then this wouldn't necessarily be true because then you'd be removing a
Oh, no.
negative number, which makes it larger. The thing I'm thinking of magnitudes, not absolute values. Oh, wait a minute.
Wouldn't that just be X plus Y? No, that wouldn't. Just be in the square.
See value comes out.
No. Yeah, it's good enough.
That's going to lead me into the same dilemma. Cheat. that's not the triangle inequality. That is. Oh, I see what they're doing. Yeah, nope. So that is clever. I think that does work. I was going the wrong way. Do this. Yes, this is going to work. Love it. Wait, look at this term here. Absolute value of x times absolute value of y. Isn't that term guaranteed to be greater than or equal to x times y? Equal if they're both positive, both negative. Greater if they're opposites. And of course, because you're squaring, you can drop the absolute values. Right? That's because what does absolute value of x squared actually mean? Absolute value of x times absolute value of x, right? Which is the absolute value of x times x. That's always going to be a positive value. Right? It's either going to be positive times positive or negative times negative. So you can just drop the absolute values there. Right? So what this means is that this has to be true. Right? And that's because that itself is x plus y squared, right? The absolute value of something squared is equal to whatever it is squared, right? Absolute value of 4 squared is equal to the absolute value of, or is equal to 16, which is just 4 squared. Means absolute value of x plus absolute value of y has to be greater than or equal to absolute value of x plus y, which is the triangle inequality. I think this can also be proved geometrically by forming a natural triangle. Let's take a. Oh, wait, did I not? Oh, I never downloaded the new version. Oh, well. Graph by hand, already did that. Let's look at this. So absolute value 3x minus 5 greater than or equal to 13. You want to solve for x. Remember the interpretation. Three x minus 5 will be less than or equal to negative 13, or it'll be greater than or equal to positive 13. Right, add 5, so we get 3x less than or equal to negative 8, or 3x is greater than or equal to 18, right? Just divide by 3. We get x is less than or equal to negative 8/3, or x is greater than or equal to 18/3. So the solution set, x is in negative infinity to negative 8/3, unioned with 18/3 to infinity. Right, so that'd be solving an absolute value greater than. For less than or equal to, right? we use the other interpretation. This would mean 8 or negative 8 is less than or equal to 3x minus 4, less than or equal to positive 8. Negative 4 would be less than or equal to 3x, less than or equal to 12. Negative 4/3 less than or equal to x, less than or equal to 4. Right, just divide by 3. Solution set here. X is in the closed interval, negative 4/3 to 4. Right, so again, very straightforward. Knowing how to solve absolute value inequalities, again, fairly important. The absolute value is fairly straightforward. Questions there? Questions about absolute values in general? See the gears turning. You're trying to think of how to phrase your question.
That's like me every 5 minutes in this class. And then there's like another question that I have to ask. And then I forget the next question, and I'm trying to figure out this question. It's. And then when I get to ask a question, you give me a good answer, so. I just gotta take it from the office hours.
Again, you have to know how to word your question, which is typically the hardest part, right? Asking the right question.
I could ask you about domains of composite functions, but that's not on today's quiz, is it?
Nope. Today's quiz, I think, is actually very simple.
Oh, it's on absolute value.
Not. It's on transformations.
Oh, wow.
This has nothing to do with this. It's just me being a little bit of a math nerd.
And you know what? I better just make a note of this. What's the process for consulting for office hours?
I'll just stay here for about 30 to 40 minutes after class. Class comes in here at 6, so I'll leave at 5:50. You can interpret what that says, I'd be impressed.
Or not to be?
To be or not to be. This shouldn't be in your notes.
I'm freaking out if it's supposed to be.
Yeah. Oh, no, I had I equals 0. And I. That's number.
Be greater than average. This is an average. Yeah, math nerd.